get it anyway. So f of x equals x cubed plus 6 for x is less than 2, and 3x squared plus 4 for x is greater than or equal to 2. So, I asked you guys to find the limit as x approaches 2. The limit as x approaches 3. The function at 2. And where the discontinuities are, if anywhere. So, just for giggles, I'm going to draw the little number line here with 2. That's where the action's happening. And I'm going to make one of these my red equation. So that's for all x less than not including 2. And I'm going to make one of these my green equation. So that's for all x greater than including 2. So filled in circle. Now, to check the limit as x approaches 2, where do the cars go? One goes here on the green one, that's the right hand side, and one goes here on the red one, that's the left hand side. So we have to test them both. So the right hand side is going to be 3 times 2 squared plus 4 equals what? 16. And the left hand side is 3. What's your name again? Riley. Hi, Riley. The left-hand side, we're plugging into the top function. So that's 2 cubed plus 6 equals 14. Does 16 equal 14? Seriously, 16 doesn't equal 14. So the cars don't crash, so the limit as x approaches 2 does not exist. Okay? Any questions on that? Where'd you guys go off the rails on this one? Anybody? That's good. All right. Limit as x approaches 3. Where's 3? 3's over here. So if we're on the function at 3, we're at that little black dot, right? Where's the car on the left? Still on the green. Where's the car on the right? Still on the green. Do we have to test anything other than the green function, guys? No. So this is just 3 times 3 squared plus 4 equals 27 plus 4 is 31. Done. Questions? Does it make sense? Remember, limits are about cars crashing, right? So if you're sitting right here on the function at 3, you have to test the left or the right hand side and the left hand side of it. If you're at 2, you need both functions, because if you move anywhere to the right, I don't care if you're at 2.0000001, you're going to be on this green function. And if you're at 1.999999999, you're going to be on the red function, right? Okay. What's the function at 2? Where do we go to plug that in? Yeah, why? Why the green function? Yeah, or visually, it's got the filled in dot, right? So function at 2 is 3 times 2 squared plus 4 is 4 times 3 is 12 is 16. Done. Where, if any place, is this function discontinuous? Is it 2? Why?
Different equations, it's at different
What are the three conditions for continuity, Russell? The limit has to exist, the function has to exist, and they have to equal each other. At 2, did the limit exist? Nah, so it's discontinuous at 2. You guys with me? Okay. So it is discontinuous at x equals 2. How about any other place? I mean, there would have to be denominators that go to 0, like say x minus 2. Actually, that wouldn't work either because we already established. How about like say x plus 5? If there was a denominator on this, then we would have an additional place where this function would be discontinuous at x equals -5, because that would make that function go to nothing. Except x is -5 doesn't get plugged into this, right? So we have to use logic every time, always. You don't plug -5 into the function that's x greater than or equal to 2.
Okay.
Right.
Yeah.
Me too.
All right. Next page. Where did I put my flipping flip? Is this where I put it? No, that's the other one. It's fine, don't worry about it. Let's look at number 3. Quick derivatives. Find the derivative for each. Do not simplify. Here's your function. F of x equals 4 times the 5th root of 2x squared plus 7. Can we make it pretty?
Yes.
How?
We take the square root and change it to power by 1/5.
Yeah, it's not quite a square root, it's a 5th root, but yeah, you get the idea, Sadie. Very good. So that becomes a power to the 1/5. So we have 4 2x squared plus 7 to the 1/5. Can we take the derivative of that, guys? Yeah. So d out dn, the derivative of the outside. 1/5 comes down times 4 gives us 4/5. Junk. 1 minus 5 gives us -4/5 for the exponent, so that's the derivative of the outside. Then we peel it off, and the derivative of the inside is 4x. One step to make it pretty, one step to take the derivative. Questions? Where'd you go off the rails? There you go. Okay, next problem. Seriously, you guys, this class had more time than the Monday, Wednesday class. Okay, and you guys averaged 10 points lower than the other class. What are we missing here? Maybe it's 8 a.m., maybe our brains aren't awake yet. I don't know what it is, but something happened between that class and this class. There's a massive disconnect. And I'm worried about that. I'm really worried about that. Because their average was 70 and change, and your average was 60 and change. And I'm not meaning 60 something, I'm meaning 60 and change. That's bad. 70 I can live with, 60, there's a problem. But you got the same material and you have more time with it. So talk to me, what's going on? Yeah.
I mean, I know for me, I should have spent more time studying limits. I spent pretty much my whole study time focusing on the derivative stuff.
Okay.
And so like that I did in like 2 seconds, and then everything else took longer. So I know for me, I should have just focused a lot more on limits.
Awesome. Okay.
I think that's what happened.
Awesome. I'm just gonna let you guys know, a limit like this may show up on your final. A beast almost certainly will show up on your final. So just be prepared for those things. So if this is something you're struggling with, come talk to me. Come talk to me, okay? All right. Thank you for speaking up. Like, somebody say something. All right, let's look at part B. Y equals 3x minus 7 divided by x squared plus 6x minus 5 to the 4/5. Now, globally, what is this? Yeah, it's a power. Locally, what is it? It's a quotient. So globally, we're going to use d out dn to take the derivative. When we get to dn, we're going to have to do the quotient rule. Here we go. Y prime is d out 4/5 junk. 3x minus 7 divided by x squared plus 6x minus 5 negative 1/5. That's d out. So now we peel the outside. The derivative of the inside is going to be u prime times v minus u times v prime over v squared and we're done. Where'd you guys go off the rails? Andy? What happened with this problem? Everybody has a different spot, so talk to me. Okay, moving on. Find the equation of the tangent line to the function of given x value. So I gave you guys y equals negative 3x squared plus 4x minus 8 at x equals 3. So if I ask you to find the equation of the tangent line, I'm looking for some y equals mx plus b, right? The equation of any line is going to take this form. So we only have x, that's 3. We need y, we need m, and we need b. Where do we go to get y?
F of x if we shove.
Yeah, the original function. So let's go y of 3 equals negative 3 times 3 squared plus 12 minus 8. 3 squared is 9 times negative 3 is negative 27. Plus 12 is negative 15, minus 8 is negative 23. So we have negative 23 here. Okay? Where do I go to get m?
No. And the derivative. Using the derivative of the original.
Yep. So y prime is going to be negative 6x plus 4. And now what do I do?
Set it equal to 0.
Do I know?
Plug in 3.
Ah, yes, I want to know what the slope is at 3, at this specific point. So y prime at 3 gives me negative 18 plus 4 gives me negative 14. And how do I get b?
Set it equal to 0. No.
I have y, I have m, I have x. I'm only missing b, so now I can just set it up. Right? Negative 23 equals negative 14 times 3. You guys have got to get here on time. Sorry, you were the straw man. Oh, yeah. This is kind of ridiculous now. It's distracting. Jesus? Yeah. So negative 14 times 3 plus b. So now I have negative 23 equals negative 28 is 42 plus b. If I add 42 to this, I get negative or positive 19, right? So then my final answer is going to be y equals negative 14x plus 19. This line kisses this function at that point. You guys have got to get here on time. It's every time I have to stop. What's your name again? Anthony. Every time I have to stop. Maybe this is part of the problem. Any questions on this one? Now you're afraid to talk to me. Anybody? Had a lot of people struggle with this one. I want to help you, but I need to know where you're going wrong. Talk to me, guys. Where's the disconnect? Yeah.
I guess for me, when I was trying to find the slope, I set it equal to 0 to 7.3.
Ah.
Right.
Do you understand why we don't set it equal to 0?
Yeah, we're trying to find the slope at a next value.
Add an x value, right? We're not looking for a maximum or a minimum here. Great. No, that's good. Because you'll never do that again. Ever. Because you're going to make notes saying, yeah, I don't do that. Right? Awesome.
Can you say that again, please?
She said you don't set it equal to 0 because you're not looking for a maximum. You're looking for a specific slope at a specific x value. So if we're looking for a slope at x equals 3, we would be plugging 3 in to get a slope out. Okay. You make custom zombie dolls. Cute, creepy. Your price function is P equals 60 minus 0.5x. P is in dollars and X is in dolls. So X is production, price is dollars. Find the following: total revenue. Part B was marginal revenue. Part C was marginal revenue at 20 plus interpolation. Do I need to say it again? I do. Please, please, please come on time, you guys. This is ridiculous. What's your name? With an M? D. What was D?
The dollar amount or maximum revenue?
Production level that maximizes revenue. So the X value that maximizes revenue, and then E, I believe, was the accompanying maximum revenue. Okay. So. Revenue. How do I get revenue, guys? Revenue is related to what? Related to price. How? Price times quantity. Revenue is price times quantity. Price here is 60 minus 0.5x, and there's your quantity. If I distribute that x, I get 60x minus 0.5x squared, and that's my revenue function. Okay? Most of you got that. That's great. How do I get marginal revenue? It's the derivative. What's the derivative of 60x? What's the derivative of 0.5x squared, or negative 0.5x squared? What's 2 times 0.5, guys? 1. So I saw a lot of people that just had 0.5x here. Raise your hand if you were one of them. It was like 2/3 of the class, so I should see like most of your hands going up. You guys forgot how to take a derivative. All right, so this is gonna carry through to the rest of the problem. If that number's off, everything's going to be off. I dinged you once for getting this wrong. If you did the rest of this properly with the wrong numbers, I gave you credit, because I care about process, right? Okay, so marginal revenue at 20 should just be 60 minus 20 equals $40. So the 21st doll will bring $40 in revenue, approximately. How many of you way overthought that? Okay. Does this help? D. Not today. Not today. Daring the door to open again. Okay. Revenue looks like this, guys. It starts at 0, 0, and it taps out at some point and starts decreasing. Where's maximum revenue? Up there. What's special about that spot? I heard it. Slope is 0. Marginal revenue equals 0. So if you take the derivative of revenue, set it equal to 0, you can solve for x. That gives you maximum revenue. How many of you got that charming little drawing on your test when you came up to talk to me about this problem? Yeah. Did it help? Yeah. Okay, so these graphs can actually really help you visualize what the process is. So, x max rev, how do I do that? Set my derivative equal to 0. And it should be no surprise that x equals 60 units. So this is 60. Questions? Now what? Where do I plug that 60 to get maximum revenue, which is, by the way, up here? Please get here on time. Please, 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 please. Thank you. So where do I plug that 60 to get maximum revenue, guys? Into the original function. I have a lot of original functions here now. Which one? Revenue. Why revenue? Am I looking for a price? Nah, so I'm not gonna stick it in price. Am I looking for a slope? Nah, I know the slope at that point is already 0. I'm looking for revenue, so I'm gonna plug it into revenue, which is 60x minus 0.5x squared. So revenue at 60 is 60 times 60 minus 0.5 times 60 squared. Should give us $1,800 or dollars. Let's make it dollars. Maximum revenue is in dollars. Any questions? What was the hardest part about this problem?
Got lost.
Where?
I got confused with the slope. Yeah, I know you gave me the graph and then when I walked to my desk, it flew out the window.
That's not uncommon. It's okay, but come talk to me, guys. I mean, you did, but come talk to me. All right, I haven't graded your homework yet, but I'll bet you money that there's a correlation between your grades and how much of the homework you actually did. I bet. Okay, there's always a strong correlation. And I haven't graded the homework yet, so I can't prove that, but I'll bet you money there will be. Okay, let's move on to the next problem. snacks for the new industry in Colorado. It's a growth industry. Your monthly total cost is given as, cost is 7,000 plus 0.001x squared. Your revenue is given as 22x, where x is measured in boxes of snacks and revenue is in dollars. So x is boxes and revenue is in dollars. So is cost, by the way, but hey. All right, find the total profit. That's part A. Part B, find the production level that yields X max, or find the production level that yields maximum profit. So we're looking for X max profit. Interpret marginal profit when 1,000 units are sold. And what's your maximum profit? What do I do first?
Revenue minus cost.
I got a what?
Revenue minus cost.
Yeah, revenue minus cost, absolutely. So I had a few people do cost minus revenue. Why won't that work? Well, let's just think about it for a second. If you have $10,000 in money in and $5,000 in money out, what's your profit?
Negative.
$5,000, well, let's try it with different numbers. If we have 10,000 in and 6,000 out, our profit is 4,000, right? Okay, so if we switch these, what's our profit gonna be? Negative. That doesn't make any sense. If your money coming in is bigger than your money going out, you should have a positive profit, right? So it's gotta be revenue minus cost. You cannot switch these. And by the way, when you subtract cost, you're subtracting the whole thing. I think I said this like 8 times in class and like half of you did this, which makes me sad. How many of you forgot to change the sign here? I have 3 honest humans, 4 honest humans. So profit is revenue minus cost. Profit is revenue, 22x, minus 7,000, minus 0.001x squared. And that's my profit function. Any questions on that? You're afraid to open your mouth, aren't you? I swear I won't bite. I only bite when like half the class walks in late. Okay. Find X that gives you max profit. Here's profit. Where's max profit, guys? Here. What's special about that spot? Slope is 0. This looks really familiar, doesn't it? So you're going to take the derivative, set it equal to 0, and solve for X. You guys are starting to learn, if you haven't already figured out, that this is the same effing thing over and over and over and over again. You take the relevant derivative, you set it equal to 0, you solve for X, you plug that X back into the relevant function to get your maximum or your minimum. So X max profit, marginal profit is 22 minus 0.002X. Set it equal to 0. X is going to be 11,000 units. And in this case, it's boxes of snacks. Okay. So that 11,000 boxes is this number right here. Okay? So put a pin in that. Yeah,
Where
Natalie.
did the 7,000 go?
Ah, what happens to constants when you take derivatives? Does it make sense?
It's
Am I in here? Am I in here? Oh dear God. Seriously, guys. I'm not gonna kill him. He's already here. Marginal profit. I've had it today. Just one more walks in, I'm gonna lock the door. Marginal profit at 1,000. So what do I do here? What did I ask you guys to do? Yeah, find what when X is 1,000,
Marginal profit,
which is a,
derivative of the original function.
which is a, you plug an X into a derivative, you get out a,
Why? Well, we
No.
slope.
yes. Okay. So we're gonna plug this X into this derivative and get out a slope at 1,000, which, you know, will be over here somewhere. We're not sure where, we just know it's to the left of 11,000, right? So marginal profit of 1,000 is 22 minus 0.002 times 1,000, which is 2. 22 minus 2 is 20. Marginal profits in dollars. So what is this, Gesundheit, what does this mean?
Everything after 1,000.
From 1,000 to 1,001, there will be approximately a drop of $10.
Go ahead, Christina.
Oh, it's, I said the price, so after 1,000, what is it, Sweetie Snacks sold, each, unit after 1,000 would cost $20?
Not cost.
Oh.
Profit increase.
We're working on profit, right? So this will be a profit increase of $20. So the 1,001st unit will bring profit of approximately $20. So Saeed, I think you nailed that. Now, max profit. What am I gonna plug into what to get max profit? Max profit's up here. We should do that in red. Why not? Max profit's up here. What do I plug in to what to get max profit?
You already have the 11,000.
Right, so I'm gonna shove 11,000 where? Into which original function? I have a crap ton of them. I have revenue, I have cost, I have profit, I have marginal profit. I've got all kinds of stuff going on. Profit. I'm not looking for cost. I'm not looking for revenue. I'm not looking for slope. I'm looking for profit. So I'm gonna plug that 11,000 into profit. I know that seems redundant and you guys are probably sick of hearing it, but you guys get really creative where you put these X values. I've seen you do it oh so many times, plugging it into random stuff, but this gives you revenue, this gives you cost, this gives you profit, this gives you slope of profit. So profit of 11,000 is 22 times 11,000 minus 7,000 minus 0.001 times 11,000 quantity squared, which gives us what, guys?
Don't look at me, I got it wrong.
You got it, what was it?
I got it wrong.
I'm looking at Nikki. Like 113,000 or 114,000? Yeah, thank you, Ryder. $114,000. So that's this number up here. Does it make sense? Where'd you get stuck? Oh shit, is that the one? Okay, I'm sorry. I'm so sorry. No wonder you're like, ooh. Little mistakes make little point take-ons, right? You forget a zero, you forget to take the derivative or the exponent down for something. Yeah, that's a 1 or 2 point cost, depending on the egregiousness of your mistake. But I want to disabuse you guys of the concept of stupid mistake. There's no such thing as a stupid mistake. There's little mistakes and there's big mistakes. So I don't want you to kick yourself over what you perceive to be a stupid mistake, because there's no such thing. Ruby? Okay. I want to see you guys kicking yourselves. And for those of you that are like, well, fuck it, I'm just going to drop this class now, I can't catch up. You can drop your lowest test. You can drop your lowest test. So it's like it never happened. So don't stress, guys. Relax. The slate's clean. For most of you. Okay. Rhea.
Because I have heads in the way and sometimes I don't get it right.
Why? Why?
No, I'm talking about if you get down like a C, I'm much rather draw the C than the D.
Why?
No, it's like, if it's your first grade, and then you get like a D later.
Oh, okay, I
So if you get a C the first time, and then you get a B the second time, and you get an A the third time, I'm much rather draw the C than the D.
Right.
So I'm much rather my first score, if it's the lowest one, to be at least higher than, you know, D was.
Right, exactly. I see what you mean. I exactly see what you mean. I would much rather have my lowest grade be higher than the D or an average, is what you're trying to say. Yeah. Okay. All right. Find the following using the graph provided. Okay, so everyone has this in front of them, so I'm just gonna whip right through it. Limit as x approaches -4. So we find -4 and we try to make the cars crash because this is a limit. Are those cars gonna crash? No. So A is D and E. B, limit as x approaches infinity. We walk the function off the page to the right because we're going towards infinity. Is y limited to a number? Clara? Yeah, it's limited to 4. As x gets really big, y stays at 4. So the limit is 4. Okay? C, f of 1. So we just take a walk at +1. I hit something solid. At what y value? -2. Okay? D, f of 0. Walk along x equals 0. Until I hit something solid. What's the value? 2. What's f of -2? Walk until you hit something solid. What's your value? 4. Over here on f, what's the limit as x approaches +1 negatively? So we're coming at 1 from the left-hand side. What's the limit, guys? 3. G, what's the limit as x approaches 1 positively? We're coming at it from the positive side. Where does it stop? Y equals 1. Good. H, what's the limit as x approaches 0? So we have cars on either side trying to crash. Do they? Over what value? 2. The limit as x approaches -2. So I have cars trying to crash over -2. Do they? Yes. Cars crash over potholes all the time. What's the y value? 2. What's the limit as x approaches -infinity? So now my function's walking off the page like this. Is there a limit to y as x gets really, really small? No limit. So the limit D and E. Any questions? J. Limit as x approaches -infinity. So watch my finger. It's gonna walk off the page towards -infinity. So x is getting progressively smaller. What's y doing? Is it limited?
I got intrigued with like, this was like a summer goal.
What?
Like at the top of it,
That's an arrow.
I thought it was like a solid goal.
Oh, I'm sorry you did that. I'm sorry.
Or do I? No, I.
Aw. Number 8. B.
So, I do see the horizontal line up there. And I think I did notice that. So I put infinity because the end is going and
Ah, but that's if y goes to infinity as well. Y does not go to infinity. Y goes to 4 and it parks there forever
Because
and
of
ever and ever.
that.
That's what that horizontal asymptote is. And here's the trick, guys. Here's the trick. What I just did with part B here is a hint as to what's coming on the next page. If you have a limit to your y value as x goes to infinity, that also defines your horizontal asymptote, doesn't it? So on the last page, perform the following limit. Also find all asymptotes, vertical and horizontal, and holes. So you get a twofer here. The limit as x goes to infinity of 3x squared plus 5x divided by 4x squared minus 8. If you take the limit as x goes to infinity and you get 3 out of 4, that's also your horizontal asymptote. If there's a limit as x goes to infinity, it defines your horizontal asymptote. So this is two parts done together. You just have to tell me that this is a horizontal asymptote. You can't just leave it blank and assume that I know that. You have to tell me that, right? Now, let's look at vertical asymptotes and poles. What do they have in common? The denominator is
Doesn't that
zero.
make this go to 0?
Vertical asymptotes and holes. Both are divided by 0. So we're going to set the denominator equal, oh, this should be 4x squared minus 8x, shouldn't it?
Yeah.
Yeah, I thought there was something missing there. 4x squared minus 8x equals 0. So I'm going to pull 4x out of both of these. And I get x minus 2 equals 0. So I have two terms with x in them. So I have to set them both equal to 0. There are two solutions to this, guys. So when 4x equals 0, what does x equal? 0. So that's one discontinuity. And this one is x equals negative 2, or x equals positive 2. Yeah. So now we have to determine what differentiates these. So vertical asymptotes are a over 0, and holes are 0 over 0. So we know what makes them in common. Now we have to differentiate them. So we plug these x values into the numerator to see what happens. And if I plug x equals 0 into the numerator goes to 0. So what is this? X equals 0 is a hole. And something like 3/4 of the class said there were no holes. So I was very sad. Yeah. And you can see it, guys. If you plug x equal to 0, what does this do? Every term contains an x in it, so every term is going to go to 0. That gives you 0 over 0, right? So now we plug x equals 2 in to the numerator, and what does the numerator go to? Let's see, 2 times 2 is 4, times 3 is 12, plus 10 is 22. So x equals 2 is a vertical asymptote. Supposed to be about that. Questions? Again, were there any surprises on this exam? Did I lie to you on that review? So if you scored in the D and F range, I want to see you in my office, or I want phone calls, or I want appointments. I want something, guys, because that was 20 people out of the class in the D and F range. I want to see you. Something is disconnected here. Either you're not doing your homework, or you're not understanding what's happening in class, which could be my fault. We may have a disconnect in learning style. So come talk to me. Raise your hand if you visited me before. Those visits help. Yeah. Come talk to me, guys. I swear to God, I don't buy that. Chocolate, tissues, tea, cozy place to relax. Yeah, a lot of chocolate. A lot of chocolate in my office. Come
You
visit
write
me.
upside down.
Yeah.
It's pretty impressive.
Yeah.
And I write upside
She's like, what up?
So you don't have to. Come visit me, guys. I'm not here to fight you. I'm here to help you learn. But if you guys don't reach out halfway, I can't do shit for you. Like, let's just call it what it is, right? This is college. I'm not going to chase you down. It's not high school. Come visit me. All right? This has been your Come to Jesus talk.
Thank you.
You're welcome. Let's talk about some new materials.